Hi, yeah, so my microphone sounds pretty good. I'm quite happy with it, but I'll have to see some videos on how it might sound. But welcome back to episode 3 for our Yummy app. Yesterday we set up our Postgres database container on Docker, and then we could see that that was up and running. So today I hope we can do much more of a design type of session rather than a code type of thing, just so I can understand what are the different requirements that I do need. So okay, so I'm on Lucidchart. I've never used this before, but it does seem like they do some form of ERD diagram. So, basics, I know, sure, existing table, proposed table, yeah. There's the comment button. Oops. Oh, is that a comment? Wait, I don't know what that does. Okay. Add different endpoints by selecting a line. Choosing from. Ah, yes, I see, okay. Oh, this is not the ERD I think I know. Okay. So for our table, oh, what does the ERD actually look like? I kind of forgot. Okay, is that how I'm gonna do it? Okay. So let's see, for our database table, let's say I have a table. What is the table gonna look like? Will I have, all right, let's say I have location. I have a location. It's just gonna be one big database, yeah. So I have a location, and then it will have a PK. Let's int this PK. I have a name of it. It's gonna be a string. I'm not too sure what the PK might be. I'm sure PK Postgres will do that. Wait, let's look it up. Pretty sure it's an integer. Serial. Huh. Oh, actually, I need to decide it. Right, let's see. Big serial. So I have a 64-bit data type size. That's actually a lot of choices. That's 2 to the 64 different choices I can have. I don't think that I'll be having that many. I don't think I'll have that much different restaurants that I'll be going to. So I'll have a big serial for that. 64 bits. Well, the rest are 128. See this insertion. It's sequential. Yeah, insertion rate. It has pretty good insertion rate. Cool. Well, this is the baseline, I'm guessing, and everything else. Seems like it performs worse than a big serial. Let's see. Insertion time, this is twice as bad. Yeah. Insertion rate. So this can do more than 1 million records. Okay, so I don't think I'll be that bad. Insertion rate compared to big serial, everything is slower than that. And table size, everything is bigger than. So I will stick with big serial for this. So the next thing is going to be our name. So it's going to be the name for the restaurant. Name for the restaurant. I'm just thinking, should I have many different tables? So I'll have a location one and I'll have a price, and I'll link these using a primary key. Oh, and I have country actually. This can be string. Actually, I might have a separate table for countries. I guess this is a composite. Should it be a composite of the location? Let's see. For country, should the country be composite of location? No, I think the country. So this country is going to refer to that. Oh, I'm not used to this notation. I only know. Oh, what is this notation? The only notation I know is oh, What does this mean? Many to one? Is that like a many to one? What is this? I'm guessing that's many to one. What I'm used to is having like the one on top, which refers to a one. Let's see, where's the chat? Many to one notation. What does this look like? It's a crow's foot. So what does a crow's foot notation look like? One and only one. One. Okay. Cardinality and ordinality. One and only one. I'm pretty sure it's at the outgoing edge that means that. So for this case, this means a country. So let's look over here, okay? So a course and a course term. So a course has, wait, okay. Let me actually read about how to use crow's foot notation. The three, okay, let's see. Showing that an individual x can relate to multiple y's, and each y can relate to at most x. So the outgoing, okay, so x can have many y's, but y can have one x. Oh, okay. The first one, called the multiplicity, is the maximum number. So this means a max of one and a max of many. And this means it's mandatory, and this is optional. Very cool. So many, this is optional. So there can be many. There must be one, at least, there must be one or many. This means optional, so zero or many. One and only one, or zero and one. So a one-to-one, so a student must have a seat. It's a one-to-one. One-to-many. So what does this mean? A course must have one lecturer, but a lecturer can have multiple courses. So knowing that notation, let's see what it might look like for us. So a location can only have one country. So a course can only have one lecturer. So it goes that way. So I'll actually change this. How do I actually change it though, you know? Yeah. Use the charts to change multiplicity. Once you click, you can click on the line in the middle and change the arrow. I can? Why can't I do that? Oh, I see. Okay. Okay. So a location must have a country, whereas one country can have multiple. Not one, but it can have many. So it can have multiple optional. But there might exist. So this means that a country. Wait, is this how I learned it? I don't feel like it is. Wait, am I like completely getting it wrong? I needed to be specific. let's see what does this mean here. So a students must have one group, but a group can have multiple students. Yeah, that makes sense. Okay. Wait, this is more of like a composite. This is more like a composite table actually, because location. Let's not call it store. Let's call it store. And then do I want the location to actually be... Wait. Let's think about this. What would a store ERD look like? I think I'm like tripping. So a customer can have multiple orders, but an order must have one customer. Yeah, that makes sense. So what does that look like for us though? So we have a store and we have a country. So, but I want it so that the store's country is located here. Database table has... Okay, let's just read this. So an entity. Customer, student, typically shown an entity of definable things. An attribute. Employee manages a team. Yeah. Let's look at it here. So Barker, so person is born. Okay, let's do this one. So person is born in one location. Okay, but like the country. Yeah, no, this makes sense. Yeah, but how do I link these two? Like if I do country here, how do I link it? So like this makes sense, yeah. So a store can have one country and a country can have multiple stores. But now how do I link these two? Like how do I join? Like what is the thing to join? ERD joining tables. Looking at this doesn't really tell me much. Team 1 ID matches with Team 2 ID. Is that what it is? Wait, okay, I don't think I'm actually understanding this right. So I'm creating an ERD. I have a store table. One of the attributes of the store table is country. I want to have a separate country table where a store has one country, but a country has many stores. I did the mapping, but how do I link these? I'm guessing I need a foreign key? Let's see. I'm guessing I do need a foreign key because, wait, or am I just tripping? Like, does country is not a string? Country.store ID is a foreign key referencing country ID. So show me an example of actual data that may exist. So this will be a foreign key. So foreign key coming out of store. Let's see. So in country we have ID, the ISO code, and name. Oh, ISO code is probably a good one. Country ID 1, 1, 2, 2, 3. Right. Is that how it used to work? Huh. Okay, so an integer. An integer as well. Use big int. Big int a thing in Postgres. Eight bytes of storage. Okay, I don't imagine I have that many. I think a normal integer will be fine. This is a foreign key. Now I have an ISO. So name, which is a string. Do I add a new? Oops. How do I add a new? Then I'll have. Actually, let's not use this. I think this might be a bit better. So store PK, which is going to be a big serial. That is thing. Big serial. Okay. There's no negative here, so it's unsigned. Big serial. So let me bold the PK. Then I'll have the name of the store, which is a string. And then I'll have the country, which is going to be an integer. It's fine because it's going to be. Then I'll have a country table, which is a PK of integer. It's going to have the name, which is a string. It's going to have the ISO code, which is going to be a string as well. So aligned to what? It's going to be a char. Really? Can I do it with ISO too? Oh, I can. Okay. Then I'll have a char. Can I have char too? Fixed length blank petted. Okay, that's exactly what I want. Yeah, I have a specific. I might as well. It's going to be char too. And then our country will link to here. So this is so not every country needs a store, but every store does need a country. One country. Because I'm guessing, I'm sure there can be different franchises between different countries, but it'd be good to, I'm sure like the specific will taste quite different. A next one I might have is like a menu. It's like so PK big serial. I don't know if I even need a big serial for this. An integer sounds fine. Let's see how big is an integer. 4 bytes. Let's have serial, because let's say serial for this as well. Yeah. Well, serial can be represented as an integer. Yeah. So int should be fine here. Yeah. So everything is mandatory. So for our menu, we're gonna have the name of the item. Yeah, the name of the item, the price. I guess I'll have it as an integer. I think I might have another table which records the price. And then this will be, yeah, and then the price amount is gonna be the amount is gonna be an integer. Integer in which 0 to 4, 0, 1, 2, 3, 4. Where 0 is, yeah. Where 0 is gonna be, so like 1, it's all been relative, so 1 is like cheap and 5 or 4 is gonna be expensive. This is our menu. We need, another thing that we need here is, we need to record what store it is with. So store is gonna be an integer. Wait, can I do it like that? So let's say, country ID is cereal. Can I write? Country B, can I write int for country? Pretty sure I can. So yeah, cereal is an integer under the hood. Good. So store is going to link to this. Let's think about this. So a store must have, it doesn't actually must have, you know, but a menu must have a store. A menu must have one and only store. Can we like duplicate menus? I'm guessing we can. Can two stores have the exact same menu? Yeah, like McDonald's. McDonald's? I'm sure McDonald's has the exact same menu. But then the problem is, I guess, like if some stores doesn't have it. So can one menu be used for multiple stores? I'm gonna say no. I'm gonna say no. Yeah. Okay, good. I think this is a good start to our database ERD. Hopefully we do get to finish, just flesh this out a bit more before we get started. But yeah, this will be episode 3, and thank you for watching.